So in light of that sort of revelation about what real response times look like, what are the ways that actual websites evaluate how they're doing? And two of the terms that we need to sort of internalize are service level objectives and Apdex score, which is sort of a simplification of talking about an SLO. But let's first talk about scalability. Again, this is a very abused term. When a student comes to me and says, I want my site to be really scalable, that's not really an actionable question or piece of advice. So you have to pick some set of things you're going to measure. And with respect to those things, you talk about what scalability means. And for software as a service, a very common one, and certainly one of the metrics of merit, is scalability means as more users come to the site, the response time for each user stays the same or doesn't get a lot worse, because response time is one of these key user-facing metrics, their perception of how snappy the site is to use. And ideally, the cost to serve each user either stays the same or maybe even goes down through economies of scale. But of course, if that's not the case, then at some threshold, you're losing money on every user. So this is what we're going to use for scalability. And that means that we're going to look at the response time for each user. How do you measure the distribution? How do you characterize how well your app is doing? And importantly, what do you do when it's not satisfactory? How do you figure out how to make it better? So the original formulation of thinking about the responsiveness of an app like SaaS, where a lot of users are doing a lot of requests, was the idea of a service level objective, which is the latency or response time to satisfy a user request. And instead of, again, talking about something like the mean, we're going to talk about what percentage of users are getting acceptable performance. So an SLO lets you parameterize this by saying, what's the percentage that you want? So what percent of users are you sort of concerned about? What are you going to call most users? What's the target response time? And over what time window are you measuring it? Right? So an example might be, I want it to be the case that 99% of requests take less than 1 second to complete, and that's measured over any 5-minute window, right? And by the way, the window is really important. Can somebody give sort of an example of why the window matters? Let's just say, suppose I omit the window and I say, my target is 99% of responses should take less than 1 second. And as long as, that's my only statement of SLO. Why is that easier for me to accomplish than if I add the phrase over any given 5-minute window? If all I say is 99% of requests less than 1 second, I can say, well, we had an outage yesterday of a couple of hours. But if you measure it over a year, then yeah, over a year, 99% of requests were really, really fast. So specifying the time window is more of a constraint because, it's like failing all the homeworks in a class and trying to make up all the points on the final, right? It doesn't really work that way. I just chose that example purely at random, by the way. A service level agreement is basically a service level objective with lawyers, right? So the SLO is a quantitative measurement that says yes or no, did you meet your stated goals? An SLA is a legal document that says, if you don't meet your stated goals, this is what the consequences are. Like we don't pay you or we get a partial refund or whatever. But a simplified way to do this is to say, look, is there a generic set of values that is probably pretty good for capturing most user-facing web apps? And that's where Apdex comes from, the Application Performance Index. You can think of it as a simplified SLO with a specific set of parameters. So you basically define some threshold latency, which is where you want to be, right? Let's say it's a second or something. You say that any request that takes less than or equal to that amount is satisfactory. If it takes more than that, but less than 4 times that, so that's accounting for that long tail, right? Within up to 4x outside of that threshold, it's tolerable. So you don't love it, but you're willing to live with it. And if it's more than that, then it's unsatisfactory. And basically, you get full credit for all the satisfactory ones, you get half credit for all the tolerable ones, and you get 0 credit for the non-satisfactory ones. And if you add all that up, you get a number between 0 and 1. Anything sort of in the high 80% to 90s is considered pretty good. Now, if you're not careful, you can also try to game this and use it to hide systematic outliers. And I will have a real-life anecdote about this coming up. But for example, if there's a particular behavior of your app that only occurs, less than 10% of the time, but it takes 10x as long, you can still get away with having an overall good Apdex score, right? It's basically saying a small number of users are going to be very unlucky, but it's deterministic. Like I know that certain actions take a long time, but I just hope that people don't try to do those actions terribly often, and therefore I'll still get a good Apdex score. And it depends a lot on what the action is, because if the action is something important, and if the user taking the action expects that that action will complete in a fast amount of time, they might not care that your Apdex score is good, right? They might say that, hey, I know it's a rare action, but when I do have that action, it's important that I get the result pretty fast. So think of it like pulling a fire alarm, right? You don't do it very often, but when you do it, you want the response to be pretty fast. So if we go back to that histogram that I showed you before, if we set an Apdex threshold of 1 second, and we say, what would be the Apdex score that corresponds to this histogram? You can sort of compute, like, here's this red section. These are all the requests that took longer than the threshold, but less than 4x the threshold, right? So basically between 1 and 4 seconds. So we get 50% credit for those. We get 100% credit for the ones in the yellow. We get no credit for the ones in the black. And if you add all those weighted averages up, you get 0.49. Not a very good Apdex score, because we're sort of, again, we want to sort of be in the 80s and 90s range. But magically, suppose we decide entirely subjectively that actually our users are okay with 1.5 seconds of time. So on the same chart, we just move t to be 1.5 seconds, and look, our Apdex score has magically improved. So is this like, a sham? No, because it depends on some good faith measure of what your users actually can tolerate, right? I mean, you could move the threshold out as far as you like, and your Apdex score will keep getting better and better. But at some point, your threshold will no longer match the reality of what your user's perception is. So there's always a certain amount of engineering taste and knowing your users involved in picking a threshold. But once you pick it, you should stick to it, right? It's a bad thing to do to increase your Apdex score is to sort of say, well, we can increase our threshold by a little bit, right? Unless you have some user research that suggests that that's okay. Or maybe you did an experiment like Google did, where they deliberately slowed things down to see what would happen. But like everything else, there's a certain amount of subjectivity, right? What are users willing to tolerate? What are they happy with? You sort of, stick your finger into the wind and set your threshold that way. So what do you do if your Apdex score is below where you want it to be? If your site is slow? And by the way, every time I ask this question, I'm going to guarantee that you get this exam question right if it ever appears on a quiz or a final. If there is a performance situation and the question is something of the form, X is slow, the only correct answer is, I need more information. This is especially true with SaaS applications because there are so many reasons that something could be slow. And attempting to fix it before you know where the cause of the slowness is almost certainly a recipe for disaster. So if you see an exam question saying like, the site's too slow, what should you do? Unless there's a really, really specific set of circumstances describing what is slow, when it is slow, is it for everybody or just certain users? You really need to drill down on that before you can sort of figure out what the remedy should be. Now, if you have a small site, you could be a little bit lazy. You could try things that are cheap, like over-provisioning, have more hardware than you probably need in steady state. And if you're only using sort of 2 or 3 servers, maybe it doesn't cost that much. And maybe it sort of masks the problem for a while. Before cloud computing, it was pretty painful to do that. Now it's largely automatic with a lot of PaaS services. But if your site is not small, you can't really do that, right? You can't provision, a 10,000 computer site. You can't sort of say, oh, I'm going to keep 10% extra capacity around, not because I need it, but because it might be there to sort of absorb the spikes and mask the real reason why my site is slow. So in fact, our only remedy is to actually dig into what are the things that make the site slow? How do we mitigate those things? And as I said, if you even decide that you're going to leave the platform as a service tier, those are the same questions you're going to have to ask and answer when you're building these mechanisms out for yourself. So next, we're going to talk about what are some of the specific ways to figure out where does the time go? How do you make it better? What services can give you insights on localizing these problems so that you can improve your site performance?